Yes, good afternoon, students. So this session we have conducted and we invited Professor Satyender Sir. He is working in mechanical department from NIT Jalandhar. So in this event, we will talk about the prototyping also in mechanical department. And in this regard, I'm really thankful to the mechanical department team also. They have conducting this session also. So I would like to invite Professor Satyender sir. He will deliver the talk about the prototyping. Thank
Okay.
you very much.
Thank you, sir. Thank you for your invitation and for warm welcome. All the dignitaries, good afternoon. For all the students, I hope it will be a wonderful learning experience to all. So, as Professor already said, I'll be taking this lecture on product development. So, most of all, I will be sharing my experiences because it will be, I think, great to share your expressing what you learned from your journey and less about the theoretical viewpoint.
Yes, sir. Your slides are visible. Please kindly send.
Okay, okay. Uh, okay, my name is Dr. Satyendra. I'm working as an assistant professor in the Department of Mechanical Engineering, and out of this, I'm also associate dean, research and consultancy. So we are also at NIT Jalandhar empathizing on this prototyping concept, which is a whiz world nowadays, as well as product design and development. From the first year, we introduced some courses which are very relevant to this all. As the idea behind this all is, we want to promote more student startups and faculty startups of our institute, and as per the idea of the government even we want to promote these activities now in academic institute. So I will also discuss what are the steps we have taken, and if it may help you to set up the same kind of things at your institute. So I hope my audience is, I think, the first year students. My presentation will be following like I will be discussing what are the capabilities of the softwares at present, or means the tools we have at present based on the mathematical things, and how uh, whatever the experimental things we have, how closely we can relate them with the theoretical things, and without much expenditures on experimentation, how we can optimize the systems. Okay, so before to jump on particular an optimization aspect, I just want to just show you some glimpses about the latest technology in mechanical engineering we have that help to set up the prototypes and help you to start your journey with the product design and development. Okay, so in the very beginning, to the students particularly, I just want to empathize on this prototyping word. Uh, from this prototyping, actually, we all mean to say, or we all mean to give you a message that if you have any idea, as a, you all has opted engineering domain, so you may be having some, thoughts about I will be as an engineer, I will develop some products, and I may have my startups. I think everyone is well and aware of these startup things now. Huh? Videos are on many TV channels. Shark Tank, one of the famous TV show as well. So many students as an engineer from very beginning they can start their journey with this all things. So what they should know in the beginning, as the engineers, what capabilities they have, what are the tools and skills they should have, so that toward the end of their journey, so they will be capable to garnish their ideas to some designs and then to the a particular product. Okay, so this prototyping all consists of these particular two words mainly. One will be the design, and second will be the development. So what will be a design? uh, that will be an individual thought that came from the society, or that can be from the personal experience or from any engineering inspiration, that they will set your goal to toward this journey of prototyping. So you will select one drawing, one design, a particular sketch or a layout or a CAD drawing. So, and then your journey toward development will start through some experimentation, some analytical exercises, some numerical exercises, some mathematical exercises. That can be through coding or software, other all things. So on my first slide also, I'm showing you uh, one heat sink on the right side of my screen. This particular one everyone is well aware of. The students, now you have seen your laptops. So on the bottom side of laptop you have seen some ducts are provided there, and on the side, if, you may sense sometime hot air is coming out from a particular slots or opening, and a blower will be keep on running inside. So this is a software view of the same thing, where we create some micro channels and heat sinks, so that this heat which will be generating inside some chips that can be removed outside, and that can ensure the safety of your equipments, electronic equipments. Okay, so these are the steps actually for prototyping. So how we can do that? So first, we will having one design of the problem that I told you, that can be real or engineering problem, and then using some mathematical tools we will start doing this exercise. And then without an experiment we will try to optimize. Optimization means we will get the best result toward our some geometrical changes or some fluid flow exercises to get a particular temperature of the such electronic circuits, as an example. Okay, and then we will implement in the exercise. So what will be the advantage of this? So we have saved huge money without any failure, only on some computer, by some computational exercises. Okay, so for this prototyping, so let me help you to grasp by step. First, a design that of your problem, and then whole long your exercises of experimentation sometime or some mathematical tool. You got some values for your input parameter I mean to say, for geometrical changes and some flow parameters. And then you will finally make your mind for the final production or development of your product. Okay, so this way your whole journey will start, and from the very first year you can. So this is just an intro with this particular which word prototyping. uh, so first, what I'm going to show you, I told you, now my slides will go with some glimpses of the but mathematical tools we have that reveal your engineering or real world problems. So real world problems can be like this problem of evaporation. See, you can consider a droplet is resting on the leaf, and as evaporation takes place, slowly this droplet will it will escape. Okay, to capture this video, all of you may the faculty members are well aware of that. Uh, we need a high speed camera, and this physics later on can be implemented in some engineering problems. So, but before to jump on application viewpoint, we need to reveal the physics. Okay, so to reveal this physics in this particular experimental problem, we need a very costly high speed camera that may cost about 10 to 20 lakhs. Okay, and we have to capture every fraction of the second. So these high speed cameras offers you the facility like you can have 2000, 4000 frames per second. Okay, then only this very slow evaporation process can be captured. Okay, so I hope that now you can assume you can relate this with the real, the way of capturing this droplet escaping as a problem. So it may takes a day, it may takes 2 or 3 hours. Okay, now on the engineering softwares or mathematical tools, we have the same kind of mimicking. We can do that. It offered the same kind of facilities to mimic that. Okay, now the point is, what comes out of it. If I talk about the physics, particularly about this evaporation, so there will be the radiation that are responsible to rise the temperature of the leaf, and then the surrounding air that having the less moisture, and then these droplets, the agitation will start on the bottom of the, on this lip surface. Okay, molecule will start exciting, density changes will occur, then molecule will escape. So these things will come, but these softwares will help you to understand how these things are happening. Okay, so you can now write a engineering problem using these mathematical advanced mathematical tools, as well as you can also reveal the physics. Okay, that will help you to write your problems later on. Okay, so I am now relating this all with the coffee ring problem. Okay, if spill some coffee, and then after some time we see these things happens. Okay, the responsible thing is the heat of the surface that actually excites the molecules, and then cause a density difference and raising them apart, and that help to roll on the individual molecule of the coffee, and that bind with it some dust particles and make a layer of it, and following obviously the temperature gradient. Okay, now I'm showing you one microchannel which is commonly used in biomedical industries, where we have to mix a particular fraction of let's say liquid, and obtain it rapidly. So we having this microchannel as a device. Okay, let's assume now this is the industrial interest, and we have to manufacture that, but we cannot directly jump on the manufacturing aspect. We need to optimize the geometry first, and then apply this, satisfy the physics which is there. Okay, the idea is now it is a three-way microchannel. So we will force one immiscible fluid that will not mix with this particular liquid. Let's say air can be there, and this liquid will be forced from this particular path, so air will separate it out there. Okay, and we will have repeated fraction of this. Again, high speed camera is used to capture this particular microchannel. So microchannel, as I'm saying, scale is very small, very difficult to visualize with the naked eyes even. Okay, so by applying this physics now, and optimizing these microchannels, okay, we are able to achieve this design and later on this development. Okay, but how we can do that without any expenditure? Through some CFD tools, through some softwares. Okay, which also facilitate you to apply the same kind of create the same kind of environment, and get the solution for the same. Okay, so another, like say, one droplet which is falling in a water pool, one of the standard multi-phase problem. So same we can mimic also in softwares. Okay, so why I'm showing you these videos, I'm just, my point is to just establish the software capabilities to assist the engineering to actually achieve this prototyping, or actually to achieve this product design and development. Okay, because this journey of any idea to a design, it actually first take the time and your overall understanding of the problem, and then it takes a whole journey of the skills actually to make a product that can meet the industry standards, or that can meet the demand of the society. Okay, so these softwares now, earlier when these softwares we don't have, and their capability will be not up to that mark. So we were keep on doing the experiments, and from experiment, from the failures we have our learning, and then we later make a product. But nowadays these are capability of softwares. Whatever is actually happening in the real life on engineering problems, we are able to assist them, able to reveal the physics of that, and then we can optimize them. Let's say if students are from the first year, then optimization, I mean to say, uh, if you want to make a jet engine, or if you want to make a aeroplane, okay, or a fighter jet, so whatever the speed you want to achieve, so it has to be first analyzed, the various shapes has to be given, okay, so mathematical analysis has to be done, then only you are able to get some geometries of the or shape of that aeroplane, okay, or that a particular fighting jet, then only will manufacture that, okay. So what should be the dimensions, so that I mean to say optimization, okay, the value of your parameters that you have to set. So now this is another problem, like say a dam filling problem. If you have to construct a dam, then how it will, how much time it will take to fill, how the when water will splash on at a particular height, then what will be the erosion rate, drag and other things we can investigate like that. So without doing any experiment in a sophisticated mathematical environment, okay, we can handle all these problems earlier. Okay, so like say if you want to see if there is a dam structure, how much penetration can be there below the dam, okay, in the soil region, okay, so this problem also can be solved, okay. So we so these things are very important, from the structural viewpoints. A turbo machinery, what should be the fan angle, so that we can get a maximum flow rate. So a CAD drawing followed by some numerical approach of mathematical numerical methods, and we are able to simulate them to a particular objective. Okay, and all these will be prototypes earlier, and then came to a particular design, and later on to a product. So you all will be fascinated if you are mechanical engineer, then all will be fascinated toward the cars, automobiles. Then I'm just showing you one video to grasp that how we aerodynamically balance these vehicles. Okay, so we have a particular wind tunnel, a big you know room, you can say, where we have facilities where we artificially create the flumes, okay, with the help some blowers or with the help of some fans, and relative to the vehicle speed that can be attained at a particular speed, so we force the flumes against the stationary vehicle, because both it will be the same scenario, whether the vehicle is moving at a high speed or whether the flumes are moving over the vehicle, okay, because relative velocity will be there. So in this case, in wind tunnels, vehicles will be stationary and the flumes or these smokes will be flowing over the vehicles, okay. So this is the way how simulations will be carried out. So why these studies are important? So that your vehicle can be aerodynamically balanced at a particular high speed, okay, at a particular turn, okay, to avoid the accidents, because the air will cause drag on the vehicle. It also reduce the power of the vehicles. So to just to ride that. This is about the particular Mercedes. They also have
Okay,
some kind of facilities at their end.
Dr. Singh.
Hello.
Hello, yes. Any student, if somebody will ask to want to ask the question, please. Professor is here. If anybody want to ask any kind of question in between the slides, want to ask, please tell. It's a very interesting session. Any session is interesting when there is a two-way channel. Means सर अकेले बोलते रहेंगे, आप अकेला सुनते रहोगे, then you get bored. अगर आप देख रहे हो, if somebody is going to observe, and you have some question in your brain, please kindly ask.
Yes, yes. Feel free to ask any question. Anytime. Anytime.
The animation and what you are watching, it is basically from IIT Bombay. So it is also from IIT Bombay, and it is all is this research work by own in IIT Bombay. So it is with very good opportunity for you to explore that kind of research in your first year, which he did in his postdoc, right? So kindly take the opportunity and take this as an advantage, right, to explore all these things. Thank you. If somebody has any kind of question, in between you may raise your hand, please ask the question, right? Okay, Dr. Sir, continue.
Okay,
Thank
okay.
you.
So I'm showing you in another video where aerodynamics of vehicle is checked by Mercedes. Okay. The idea is actually to understand the aerodynamics of the vehicle so that the drag, if there is a drag, or let's say, in the automobile, there is a huge competition in the market. Okay. So there are so many models are there, and if a particular company has to sustain in the market, what they have to do continuously, change in the design. So every change in their design led also the foundation to the technical, technical satisfaction of the physics which is responsible there. I mean to say, for every vehicle design, there will be changes in the aerodynamics. So I'm showing you some, actual pictures and their simulations we did actually. See, so without doing any experiment, because these wind tunnels is not easy to construct everywhere. It requires huge investments. So to avoid that, what we can do, we have the softwares now, dedicated mechanical engineering softwares. So we can use them, and without any wind tunnel that these companies had, uh, so we can simulate these all in a computational environment under the same similar conditions. Okay. Again, my message is, you must if you have to start your journey as a student from a student to a startup engineer, or you want to achieve some engineering expertise during your engineering, so you must know about what are the softwares are available in the markets, and up to what extent you know without spending a money on the experiments, you can have your proper design, and then you should develop that. You should go for the manufacturing of that. Okay. So from this particular video, uh, on a software we created their CAD drawings. I hope that everyone is well aware of the CAD drawings. So CAD drawing will be the actual replica of a physical domain on a computational domain. Okay. So means, particularly specifying the coordinates, we will create the same design that we are having in the form of a sketch, or that exists physically. Okay. So now in the same, like say, what can be the maximum velocity of the speed of a car, so same will be provided in a controlled environment, and you can see what we should be well aware of, this particular drag, and how the air is gliding over these structures. Okay. So these softwares, they give you the more deeper understanding of the physics that will be followed by the air, that cannot be easily understood even in a wind tunnel. Okay. So this is just a showcase of the the softwares and mathematical tools that help you to design and optimize your structures. So this I already discussed earlier. So these are the zoomed image of the heat sinks that are actually used for your transformers or electronic devices to maintain their low temperature. Okay. These are again the microchips, integrated circuits, and their cooling heat sink designs. Okay. And these colorful images are showing you what is the temperature is maintained, and how the heat transfer is taking place around these electronic circuits. So we all are knowing about the submarines also. Okay. So submarines has to face a huge drag because of the water, which is highly viscous compared to the air also. Okay. So that will be a big challenge to actually when they have to speed up in the ocean. Okay. Or for every underwater vehicle. So these also can be simulated. Even though if you want to want to change the existing design of a submarine, so we can take the same kind of design or new designs to the software environments, and there we can simulate them, applying the same kind of conditions that they have to face later on, and we can optimize our geometry. Okay, so we can do the various changes in the geometry so that a goal can be achieved. So I'm just showing you one animation that we have obtained. So now the submarines are also like a fish kind of structures. So these are called as fish like locomotives, okay, inspired from various fish structures, so that they cannot be captured easily under the radar conditions. Okay, so some confusion can be created in the submarine designs. So these are the various submarine designs at present. So let's say this can be the idea of any particular scientist, that to create this illusion, why not submarine design from a conventional one to a fish kind of structure. So this is the idea. This, I think, this particular thing can help you to understand this prototyping as well. So what should be his journey? So he come with a particular kind of fish structure that actually in a real world that having a very less drag. So generally we all know that the shark having fin structure that is super hydrophobic in the nature, which is water repellent in the nature and do very less drag actually. Okay, now this is a real problem we have now, how to uh, create a submarine out of it. So there are many challenges will be there. How, number one is, what should be the design, or more design changes are required, whether the feasibility in the real structure is there or not. Okay, I mean to say, from the manufacturing viewpoint, from production viewpoint. Okay, whether same standards can be achieved or not. Okay, so these things can be earlier understood in some mathematical platforms. Okay, so same kind of structures we can form there, various structures can be analyzed toward this particular objective. Okay, and then we finally, once we have the particular dimensions that well satisfy the physics, then we go for the manufacturing. Okay, so steps in product design and development. So my earlier slides are just the glimpses to tell you, to brief you about what are the software capabilities we have, and using the softwares without spending a single money on your experiments. Okay, you can create your designs, then you can create your design standards. Okay, you can have some dimensional values which are relevant to your product outcome, and then we should go for the particular development side, manufacturing of your product. Okay, so as a student also, from the very first year you should start your journey, and then how your journey will start, that will coming in up my upcoming slides. Okay, so prototyping in all over. So as I already told you, there will be design, and then there will be some mathematical standards, mathematical tools you will follow, although you will do some experiments on your design, and then check your capability, and then evaluate it. If it will be satisfied, then it is okay, and then if some changes are required, so you have to change your design again and again. So this is exercise will keep on until your final goal has been not achieved in terms of some geometrical dimensions. Okay, so overall, this flow diagram will help you to understand what are the steps in the prototyping. So first you have to recognize the need, and then a problem formulation will be there. I will help you to identify the problem, and then gather some information. Okay, means, let's say this your problem maybe a social problem, or it can be some inspiration or whatever, and then that has to be now dimensionalized. That dimensionalization will be called as a problem definition, means a drawing has to be created of that. For example, if you want to make a design of a mouse, computer mouse, then you have to give some dimension to that. So that particularly is the problem definition. And then information has to, if you directly want to go for some manufacturing, then what should be the material, suitable material for this. Okay, and other related aspect for manufacturing. Or if you want to conduct some simulation, what software should be there, what I have to conduct as a simulation, what should be the conditions for that, other things. This information has to be gathered. And then concept generation, followed by concept selection, then communication, then detailed design analysis, and then finally your first prototype will be formed. So prototyping is actually also sometime is considered as a non-dimensional form of your actual product. Okay, non-dimensional, I mean to say, let's say if again we are going to jumping again to that submarine problem. If you have to build a submarine, then how it is possible to test it. Okay, because it is huge in the size. So what we'll do, we will make a small non-dimensional prototype of it. Non-dimensional, I mean to say, I think if a student from first year, it will difficult to digest them. uh, Considering what should be the aspect ratio, means larger or smaller dimensions to a actual problem or design, that will if you divide them, then 0 to 1 based on values will be generated. So that can be maintained on a small scale also. So that will be called as a prototype. So whatever will be tested on that, same physics will be applicable on a larger object also. Okay, so that sense is also taken from the prototype. Or it can be the, or in some cases, because this cannot be generalized, what I'm saying earlier, sometime whatever, before to launch any product to the market, we create a prototype of it, means similar kind of thing, we similar kind of product we will create and analyze it, test it for the, for its durability, and later on, the if you test it properly, then we launch our commercial product. Okay, so okay, 1 minute. So this particularly I want to emphasize problem formulation. So as I told you, as an engineer, you may be aspirant to having your startups later on, or you want to be achieve something in form of your minor or major projects during your BTech. So what should be the problem? Obviously, as an engineer, our goal is to assist the society, to add human ease through any product, through any process. So your idea must be can be a society driven problem. So society driven problem, I mean to say, uh, let's say you see sometime take a look around you and you see there are some challenges to the human being. Okay, and you want to add ease to the human being there by launching some product. Okay, as an engineer, you see, this is a problem to the society, so why not I should launch a product for this. Or it can be your personal experience as well, like say in your day-to-day life, in your hostel life maybe, or in your college life, you may be facing some challenges to kept something or to have something in your room. So for that also you can launch one product. Okay, so your problem formulation can be spread to that also. Or sometime your society or personal experience, it can be like let's say you belong to a very hilly region, let's say for Leh Ladakh region. So there everyone know snowfall is there, and winter lasts for 5 to 6 months. Okay, so that become a societal problem. And now you as an engineer, you want to launch any product to add the human is there, human is there. So let's say if it is a uh, in the winter, what will be the requirement? Then space heating will be the big challenge to attain there. So as a product, electrical heaters can be optimized there, or solar heaters can be provided there. So they can be the product for such problems. Another example for the societal driven problems can be, let's say you belong to the Punjab, then Punjab is agriculture state. Okay, you may be seeing some farmers, they are facing problems in their day-to-day life related to the agriculture exercises, so or applications. So you can add some there, so that can add ease for their working. Okay, so that problems are actually the society driven problems. And personal experiences, as I told you, let's say you are traveling in the train and you may be wondering that you oftenly have observed in the train that there is a, table that is only for the guys who are sitting just next to the window. Okay, but what for the other persons? So why not they are also paying the same amount? They are not getting the table when to sport there, when they have the meal and other things. Okay, so can be personal experience. So you can make some design so that it can be later on folded up to a small sized table, but can be extended to the all. Okay, so that can be personal experience. And as I also told you, day to day experiences also, that can become inspiration and taken as a problem. And then it can be national or international interest as well. Let's say uh, you may be visiting sometime, let's say ISRO, DRDO. Now, DRDO, after this particular battle between India and this particular war between India and Pakistan, they have launched a number of problems on their website. Okay, related to the drones and other warfare equipments. Okay, so that is actually national interest now. So as an engineer also you can contribute there. And international scenario can be, let's say global warming is there, why not there should be a overall solution to the industrial waste. Okay, or other ways for to lower on this global warming aspect. So there are international interests as well. Or if there is international market for a particular product, why not from India we should participate there. So there are things like that. Uh, so uh, uh, these 3 points are covering actually how you can decide your problem particularly, because your prototyping will first start from your design, and that design must be a true motivation to you, so that you can follow your interest to a longer journey, and then take that, finally get that into form of a product. So in the same way, we also inspire our students at NITJ from the very first year, so that they must start with some ideas and keep on working up to the final year on these ideas. Okay, so I am taking another example uh, from where our journey started at NITJ, particularly my research group. So we are aspirant. We have taken some problems of space heating particularly. We see that the Indian Army is deployed in Siachen also. uh, about 10 lakh of the army or forces they are actually deployed on this Indian China border there, and they have to sustain a huge winter there. Okay, so many startups are there who are contributing in the form of some products to add ease to their day to day life. Okay, similarly we have taken look across the country, like Rajasthan is one of the largest chili producer. So if some product will be there that can produce a hot air from the solar energy, where solar energy is available in good amount across the country, particularly largely in Rajasthan and Gujarat. Okay, whenever it is available in a good amount across the country, so utilizing solar energy, and for this particular kind of application, providing hot air, we are able to achieve many applications like fish drying in coastal regions, chili drying in Rajasthan, that can help to attain chili drying in a controlled environment that will maintain the quality of their chili. Okay, similarly for fish drying, and for particularly the residents and the army and forces which has to live in particular these cold regions around the Himalaya. Okay, so we come up with the idea as a product called as solar air heater. uh, so for this prototyping, uh, the designs we actually created ins- inspired from this particular application of requirement of hot air for various applications, as I told you. And then we come up with, from our fundamentals, with some designs. Okay, then challenge was to actually uh, test these designs under the physical conditions that has to be actually imposed when these product has to be worked on. So we created artificial facility at an NIT Jalandhar in the lab, where cold environment is created and solar flux is provided, and these designs are tested under first under mathematical forms by developing our own codes. I'm just showing you some glimpses of that. This whole exercise is done by some BTech students, some PhD students, and some MTech students as well. So before to step by step, let's discuss about it. So our motivation was clear: to produce hot air from the solar energy and to assist the applications like space heating in the Leh Ladakh regions, and product can also achieve the application of fish drying and other agriculture drying applications. Okay, that can be also added to the greenhouse. And then this motivation was clear. Then what was our next step? Now design must be there. That came from fundamentals of heat transfer fluid dynamics, and then we have to apply the artificial conditions to these devices, whether they will work or not. So that we achieve mathematically from our some codes and some using some softwares. Then we develop our prototypes. Once it is established mathematically that these systems can work, then we start fabricating them. Because in fabrication, because these all devices has to work outside under outdoor conditions, then uh, what should be the materials for their casing, how to actually weld them, because there are various components of these devices. So how to attach them, how to maintain the proper gaps. Okay, so we start building them, fabricating them with some raw materials, and testing them for some standards, because these systems must be insulated from some of the sides. Uh, Let me briefly tell you about this system. Solar energy actually fall on a particular observer, which is underneath of a transparent glass cover. That actually this glass cover actually help these systems to be not this collector not to become in direct contact with the surrounding air, and then we force the surrounding air, cold air, through the system, and that was convected with the collector and get in terms of the hot air outside. Okay, here you can see air is provided in, and hot air is coming out. Okay, so this system has to be properly designed as per the physics is concerned. Okay, so what should be the material for the casing, for the individual component, and how they can sustain under the weather condition, under the snowfall conditions. So that will be the challenges for us to establish this particular commercial product later on. Okay, so likewise we keep on developing that. And there's another challenge with the solar energy, which is it is only available in the daytime. So let's say sometime clouds are there, and solar editions are only available for some time. So there we come with another design of solar thermal energy storage system, and that is attached to the solar air heater as well, so that take the heat in the daytime and leave it in the nighttime. And you can see that it can provide the hot air up to the 24 hours. Okay, so this way we are keep on fabricating and testing our designs, prototypes. So all these are prototypes, and now I'm just showing you later on. This is the final product that we developed, which is now up to the commercial standard. Okay, but before to finally launch this up to the market, we also tested it in our mathematical softwares. Okay, that help us to understand the physics of it. And once we have some geometrical dimension which suits the overall design and other technical aspects as well, then we conducted the survey. That was a part of your prototyping, is gathering the information what material suits well, uh, and then we fabricated this commercial product, as you can see, and tested for 1 year for its working. And then we commercialized this with the hotels industry of these regions and with the Indian Army as well. So national interest. So another case study I will take. So we have taken one problem from the ISRO also. So this is example of a national interest particularly. So ISRO, everyone is well aware of this particular agency, which is keep on contributing, uh, to the satellite domain, to the various spaceships we are launching to the various planets, okay, for their surveys. So we are very proud to, as a nation, the ISRO is contributing this domain, and we are one of the top countries across the world because of ISRO only. Okay, but there are also some problems, and engineers has to face every day new problems and new challenges. So what challenge they shared with us, uh, I'm also showing you the picture of satellite there, and missile system as well. So each of the component that has to work or deliver there in the space has to be tested before to attach into this whole system. Okay, so for this particularly, what they have also created one artificial facility at the ISRO, uh, where they are testing every critical component, mechanical component, in a vacuum condition under the very high temperature and under a very cold temperature. Why they are testing it under high and cold temperature? Because under the when any of the space vehicle enter to the space, the surface has to be experienced plus or minus 150 degrees Celsius temperature, because of when they have to face the solar radiation and when there is a no sun condition. So accordingly, temperature varies there in the space, and each of the component under the vacuum condition has to wear this severe change in the temperature. So what ISRO has done, they has created artificial vacuum facility uh, at Ahmedabad center, and they have designed one plate there, which is called as thermal plate, and they sandwich every mechanical or electrical or electronic system there and test them within plus minus 50 degrees Celsius temperature. Okay, so uh, they want from us that we have to design and develop a thermal device for high efficient cooling and heating. Okay, under the vacuum condition. So we have taken this as a problem to design a thermal base plate inside the thermal vacuum chamber that has to improve its efficiency in terms of heat transfer. So what this will be a final product that we have to that we have to deliver. So what should be the steps for that? First, a design of a particular thermal plate and that vacuum chamber. Then we need the conditions for that. What is the actual conditions that it has to be experienced later on in the space? Okay, that has to be imposed. And what should be the geometry and what should be the other parameters which has to be manufactured later on. Okay, so all we did that in the CFD is actually computational fluid dynamics. So there are softwares that actually implemented that mechanical physics on such problems. Okay, and that give us a, in terms of a result, geometrical details, means size of your thermal plate, and other measures that we made actually, okay, to get a high efficient thermal base plate. Okay, so once we have these values, then we create one prototype and then launched one our product. So I just telling you briefly about this all, uh, up to a particular limit that is allowed from ISRO side. Okay, so this is the existing facility they had. So they were they having a treated cold and hot fluid. Okay, uh, and that is actually forced through these tubes which are attached to the thermal plate. And this is, in the background you can see this black one is the thermal plate having thickness of 5 mm. This is a cross section of the tubes where the fluid is forced to enter inside. Okay, so fluid is forced through that and it has to follow this path and then come out. And during this path, it is heating or cooling the plate. Okay, as we can know, there is a particular distance is maintained between the tube during this path. So heating and cooling can be maintained around the tube only. Okay, so they are not able to achieve the high efficiency during the cooling and heating cycles. So uh, so in earlier analysis, what we propose these wavy structure so that more heat transfer area can be increased. Okay, we also uh, uh, implemented fins and fins inside the tubes to increase the heat transfer area inside the tubes also. But later on we come up all these steps up to ABC3 designs. They are also providing huge pressure drop during this operation. So we come up with this particular design from our fundamental, that whole fluid, which is treated fluid, hot or cold, will be forced through a plate that is called a jet plate, and there should be established direct contact of the fluid with the thermal base plate. Here, in all earlier provisions, the treated fluid was not in thermal contact with the thermal base plate. It was flowing only through the tubes, and then from tubes to plate there was a heat transfer. So in this particular design, there is a direct contact and high efficiency can be achieved. But this was just a thought to from thought to a product. So I'm just sharing you my journey with you that will help you to understand this prototyping and particularly this theme of the today's lecture, from design to development also. So there's some various fin designs that we implemented. Okay, but later on these are the wavy uh, tubes we also implemented. Okay, so later on we come up on this particular design, but this was a very hypothetical design. And then we created first the drawing of it on a CAD software, and then from CAD software we implemented it into a CFD software. Okay, so we utilized the ANSYS Fluent. So all mechanical engineers, please remember there are some tools which are highly, students who are well trained on these softwares are highly demanded in the market. You can directly search on LinkedIn, you will find many CFD jobs will be offered by various companies in the LinkedIn, and many skilled engineers are required there. Okay, so ANSYS software is there, ANSYS Fluent. Then COMSOL is there, Star CCM is there. These are the softwares who help you to solve such problems. So we are able to maintain a very low temperature during the cooling cycle of these systems. And at the same time, what are the earlier ISRO designs we had up to 3? You can see the design 4 is at a very low pressure drop, where other designs are offering very high pressure. So because of this particular design, we are able to mathematically up to this stage, mathematically able to achieve what goal we have to achieve. And then it is a time to implement. Then at the ISRO, we start fabricating it with their advanced manufacturing facility. So this is particularly shape it takes from this particular design, which was just a sketch. Okay, so after following a huge exercise on many softwares, okay, so we start testing it now under the real conditions. So now I'm glad to share with you, this is the actual thermal vacuum chamber there they have, where we are able to maintain almost zero pressure, similar vacuum conditions that we have in the space. And then this is installed inside, and we mounted various electrical packages for it who create the heat under these conditions, and that is also provided plus or minus the temperature. Okay, you can see this facility there. So another picture of the same facility. Okay, so this is the results that comes as outcome. So you can see when we are putting this whole device under the cooling cycle, you can see at various location what we did, we have applied the temperature sensors on the top surface of this particular device, so that we can see the gradients everywhere. So we can see following a very less slope, within a few fraction, this whole device is able to maintain a very low temperature, keep on maintaining that temperature up to the minus 20, 30, and then instantly it is rising up also. So that saved huge cost of the ISRO, that is the earlier investment they had. And we have implemented this in the existing facility for testing every electrical and electronic equipment that has to be part of space vehicles later on. So overall now, moving toward the conclusion. Okay, so our journey will start with the initial planning. That can be the thought I told you, inspired from society, from personal experiences, or driven from a nation or international interest. And then from planning we start our execution. So execution we start with the particular design, and then analysis of that design. That analysis can be followed some experiments or some mathematical exercise, as I discussed throughout my lecture. Okay. And then time to implement. Then we test that under the real working conditions, whether they will work or not, their durability, flexibility, mechanical strength as well. And then once it will be fulfilled, then it will be launched as a commercial product. Okay. So during this journey, many time now this 3D printing also help us. Okay. So for our many of the other challenges, let's say we are presently working on one swirl problem. uh, we actually want to contribute, for a heat transfer problem that came from industry. They want to cool down a particular plate at a very high temperature, and they want instant cooling there, so we are implementing a swirl air jet kind of thing. So using this particular, uh, 3D printing, we manufactured these nozzles who actually create these swirls, and tested them under experimental conditions within the lab under indoor controlled conditions, and delivered the product to them. So what it follows? So these 3D printing actually need one CAD drawing. Okay, that CAD drawing, uh, you can conduct some mathematical exercise on that if it will required. So finite element method, that is also another domain to do the structural analysis particularly. And we have CFD tools that I already discussed to do heat transfer and fluid dynamics related exercises there. So once your drawing is well, analyzed through these tools, and you want to implement that, so first prototyping can be done through the 3D printing. So now students are well aware of 3D printing. So by layer, it will be keep on depositing various polymers. So metal 3D printers are also available nowadays. Okay, even a metallic structure, except machining, can be directly created, using the uh, molten metals. So similarly, structures can be created in to their 3D layouts, and then they can be tested experimentally to their feasibility. So some example of that. So this is the nozzle that I'm talking about. So we designed these nozzles to create actually the swirls, and then using the help of 3D printer, we created, the same structure which we designed in a CAD software. We manufactured using the 3D printing, and then we tested later on. Okay, so with this, I will thanks to the audience, and I've been open for all the questions. Please feel free if you have any question related to this presentation and this idea of prototyping.
सर 3D प्रिंटिंग का जो से कैसे यूज करते हैं 3D टाइप प्रिंटिंग का
Um, if I'm not wrong, the question is how to use 3D printing. Is it the question how to use 3D printing actually?
प्रोटोटाइप
Okay, okay. So actually, this require mathematical coordinates earlier. Every mechanical, either it is a machining or either it is a directly layer by layer creation of a 3D product, they need coordinates. Okay. So whether, or even though if you have to do any CFD analysis or any mathematical tool you have to use for your simulation, it needs a space. Space means mathematical space. Coordinates is required. So we need to first create that. So that can be done with the help of codes by specifying your coordinates, or with the help of some CAD drawings. So there are many CAD software, SolidWorks, like say AutoCAD, ProE, similar to that. So there you have to first create the drawing of your 3D problem, and that as a command is given directly to this particular machine of 3D printing, and taking the information of the coordinates, it keep on depositing the layers of the fused material. Sometimes we have various polymers we are using in 3D printing machines. There are some heaters inside that melt the material and keep on depositing that. This is the way 3D printing actually works. Or I would add, if you have any question, like, uh, how to start your startups, how to finally uh, manufacture your products or launch your product, how to do the commercial things later.
Yes, yes.
Sir, how can I use like prototyping in entrepreneurship? Like if I want to start a business or I'm planning to start a business.
Okay, I'm not completely got it, but I think the question is how you can start with startups, huh?
Yes, sir.
Okay, okay. This is a question for that I was waiting actually. So now most of the institutions having TBIs, that is Technology Business Incubations Centers, TBIC. Okay, we also having at NIT Jalandhar. The idea of these centers is actually to inculcate the ideas of the student from their thought to idea to design, then help them to with these mathematical standards or experimentation to finally come to a product or prototype. Okay, so once this journey will be achieved, then you finally have one product. That product now can achieve some commercial standards, means that can be ready to launch to the market. Okay, so there comes the role of the startup. So this whole journey from thought to the product development is called as actually your startup. Okay. So now you will have this startup. So for this startup, actually, you need to have one firm or a company. Okay. Firm means LLP, partnership firm, and a company you have to start with, so that you can register in some TBIs like Technology Business Incubation Center. Here at in Punjab, NIT Jalandhar, you have this facility center, and then IIT Roped as well. So this firm will be registered there, and you will share your idea with the experts of these institutions, and they will nourish your thought to take up a product. Okay. So once this product will be ready, so funding will be provided to you from the government as well as from these institutions directly, and then these centers will help you uh, to do the marketing of your product. They will help you to link your you with some industries which are relevant as per your product, and then they will assist in the selling of your product. So this is the whole journey. So starter means from thought to the final product. Okay. And I forget to share, the Startup India itself is a, step of the government of India. There, if you have any firm or company, you can directly apply there for the funding. Our students already have taken funding from the Startup India directly in up to the 20 lakhs they are giving directly only on your thought without any execution. You only have to uh, put your pitch there. What is your idea? How it can be turned to the business only. Okay. Likewise, Shank Tark is there as a show you can see on the YouTube. Okay, these are the funding companies also helping the students to to achieve a particular product.
Sir, I would like to ask, how do you go about learning about CMP softwares and how to implement them and how to be good at them in the market? Like really,
Sorry, I didn't get that.
yeah, sir. Yeah, sir.
Jagdeep, can you tell that?
Sir, actually, he want to ask that that how that CMP and CMP softwares are working and what is it?
Okay. Actually, all these softwares actually need your design, CAD drawing first. Okay, all these softwares like CAD softwares or CAE softwares, we call them CA softwares overall, computer aided engineering. Okay, so they follows particularly three steps. Step number one will be the design, that is actually drawing. CAD drawing means information of the coordinates of the geometry. Okay, second step will be the conditions, boundary conditions in terms of mathematical boundary conditions, means a real condition to a mathematical condition. Means if you are studying thermodynamics, then thermodynamic system is there. So likewise, what is interacting with the system through the boundary and what changing it is doing inside. For example, you are in this ventilated air conditioned room. So before you enter this room, the temperature was about 30 degrees Celsius or 40 degrees Celsius. After some time, once conditioned air is supplied to or added to this room, then the temperature start falling. So your interest actually to analyze the temperature of this room. Okay, and it become a thermodynamic system separated by ball and surrounding whatever. Okay, so that drawing of this room has to be imported to that software. And similar condition, so air is supplied from some of the vent at a particular temperature and at a particular mass flow rate. That has to given as a condition, boundary condition in that software, that will give you result in the form of temperature distribution with this room and velocity changes within this room because of the fans which are working or whatever the way air will diffuse inside. Okay, so this is actual way of CFD working.
Analysis.
Sorry, I didn't get your voice is breaking.
How to use prototype in data analysis.
How to use data analytics?
Prototype in
Dr. Jagdeep, can you help me to get this question?
So basically, she is asking how can we use prototyping in data analysis?
In data analysis.
Gee,
Actually, the question is in a reverse way. Uh, Prototyping is actually your final thing that you will get after the data analysis. Actually, you will have one design. Let me put it in a flow chart again. First, you will have design. That will be your actual sketch of a problem और जो भी मार्केट में प्रोडक्ट लॉन्च करना चाह रहे हो उसका डिजाइन. Okay, then it follows data analysis. The data will be relevant to the consisting of information under what condition it has to work or what it has to deliver, and then you will launch one product, or that will be just a mimicking of your actual product. Okay, that is called as prototype.
Yes, any student, anyone else who want to ask the question? No, sir.
सर आई वांट टू आस्क कि एज अ मैकेनिकल इंजीनियरिंग स्टूडेंट हमें इनिशियली कौन कौन से सॉफ्टवेयर आने चाहिए?
Okay, a very nice question. It actually, which software you have to learn all decide upon where you want to land up. I mean to say, a mechanical engineer can be who actually know the how to develop the softwares, or another mechanical engineer can be a good user of the softwares. Are you getting? There are huge difference. One is who's developing the mechanical softwares, and another mechanical engineer will be who's a good user of the software. Accordingly, his journey of the industry will start. One will be the industry who is developing these costly softwares. Okay, so this ANSYS, I'm particularly using ANSYS software, whose CEO is a mechanical engineer from IIT Bombay. His interest was to develop a mechanical software. So he, after his mechanical engineering, he did his masters from Cambridge in CSC, and he also obtained PhD in CSC. So his interest was to develop the software to mechanical engineers. And ANSYS is at number 3 across the world, and US also it is at number 3 in terms of softwares who having highest revenue. So this is one journey. Another is industry who having the mechanical products like say automobile sector. Okay, at automobile mein, there is not only the one job to check the aerodynamics, but to do the structure analysis as well. What should be the alloy structure? What should be the other structures? Okay, so
Jyot,
for
questions?
these also we need to now do the analysis in the softwares. So mechanical engineer who want to work in the R&D of the industries, he must know all the CAD software is CAD software is common to all the fields of the engineers. It is the mandatory to mechanical engineer to learn the CAD software. Over that, all CAE tools, computer aided engineering tools, that can be CAM softwares and that can be any ANSYS kind of software. Okay.
Any other student?
And we also offers trainings on these softwares. So during your summer or winter vacations, you can join at NIT Jalandhar. Okay, so you can do our internships with us also. So we'll help you to understand and start your journey of as a CA engineer there.
How do you know if a prototype is good enough to move to the next stage of your project?
Dr. Jagdeep, you have to intervene again. Uh, I didn't get the question.
How do you know if and when a prototype is good enough to move forward?
I'm not getting the question. Please, somebody.
Sir, she is saying that how do you know that your prototype is now okay and you have to move for further stage?
Okay, a prototype is actually a replica of your actual product that you have to launch in the market. Okay, we are believing that. So your prototype has to test it under the same conditions where your actual product has to work later on. So you have to test it under the all the conditions, similar conditions. Okay. Likewise, discuss my one of the prototype with you, and now that become a commercial product. I told you we have created one device that deliver hot air under the cold conditions. So how I come to know that can deliver? So I have to artificially create the same environment, cold environment. Okay, that we achieved under the cryo conditions at an ITJ. Okay, so there we ensure it's working there. Then only we launched our commercial product.
Okay, sir. Thank you very much for your delightful lecture. We are very much thankful to you, and I'm also thankful to all the students who bear patience for 1.5 hours and listen carefully. So actually, you are having the age of this that you are creating mess. Okay, you are right now in the age of a student, but still, I expect that out of you, only if 20, 30 students are able to get the idea what we want to convey here. So we are successful. So I'm very much thankful, Dr. Sindhu, for your lecture and for your time. And we are very happy if you come sometime to our campus and give us more beautiful lectures like this in the future. Thank you very much, sir.
Thank you, Dr. Jagdeep, and thank you for this wonderful audience for their patient listening, and for their wonderful questions as well. Uh, from my side, I'm offering the students are feel free to interact with us with me anytime. You can write me email. You can contact me also on my mobile number, and feel free to have internships with us also. Okay. Uh, so this all from my side, and thank you, sir. Thank you, Jagdeep.
Thank you, sir. You may use it. Thank you.
So may I leave now?
Yes, sir. Thank you. Thank you.
Okay. Okay.
Guys, just wait for 2 minutes. Let us first calculate, collect these attendance sheets. And please, students, थोड़ा ध्यान से सुना करो